Hi everyone. So this is our BGP troubleshooting lab 2, and let's go over the topology. Right. Um, Here we have uh, 5 routers. Okay, and router R1 is in 65001 AS. Right. R2, R3, and R4 are in AS 65002, and router R5 is in AS 6500. So between R1 and R2, we have an eBGP link. Between R2 and R3, it's an IBGP link. Between R3 and R4, it's an IBGP link. And between R4 and R5, it's an eBGP link. Okay. So R2, R3, and R4 basically act as a transit for between communication between R1 and R5, okay, which are in separate AS. So we can see that R1 is originating a couple of routes, right? And R5 is originating a couple of routes. Okay. So these routes from R5 should reach to R1, and from R1 it should reach to R5. Okay. And yeah, all those basic details have been mentioned here. The problem statement is that the customer on R1 has two networks, right? And the partner network needs full reachability to and from uh, R5, right? So we have few networks, few routes from R1 and one from R5. But as of now, the reachability from uh, each other from R1 to R5 and R5 to R1, these routes are not reachable. Okay. So that's the whole problem. So let's start looking at it. So let's log in into R1 and see if we can reach out to R5. So as of now, we are not able to reach out to R5 from R1, right? None of the pings are working. Okay. So let's log in into R1. So now let's log in into R1 and we'll see what's the issue. Okay. So let me see if uh, all the BGP is formed, right? And I can see that the neighbor 10.12.0.2, right? The neighborship is formed, right? And I'm even sending it to prefixes, right, to my neighbor. Uh, let's see which prefixes I'm sharing. Show BGP, IPv4, unicast, neighbors. This is my neighbor. Yeah, so you can see that 10.1.1.0 and 10.1.3.0, right? These two prefixes which we have connected on R1, right, are being sent to R2, right? But now let's log in into R2, right? And let's check if here we have, right? Here we are seeing that from 10.12.0.1, right? First of all, both sides, the neighborship is fine, right? It is working, it is up. But from 10.12.0.1, we are receiving one prefix, right? We saw above that we are sending basically two prefixes to R2, but it is receiving only one, right? So ideally, it should receive two prefixes from R1, right? So there is something which is preventing, right, from whatever routes were sending from R1, right, getting stored in R2. Something is preventing that, right? So how can we check? How can we verify that, right? So let's first try to see the configuration on the device, right? All this basic interface configuration, right? Now this is router BGP, correct? And this is this is what I'm seeing is prefix list, right? And this prefix list is having a permit statement of 10.1.1.0, right? But we have two routes, right? 10.1.1.0 and 10.1.3.0, right? So how will we allow um, both the routes, right? The prefix list is only allowing one of them, right? It is not allowing the uh, other route, right? Therefore, that is rejected on R2. That route is not allowed on R2, even if R1 is sending that route, right? So we need to fix this prefix list, right? Um, so we can even verify, right, which route we are actually getting from. mm, Right. Yeah, you can see that 10.1.1.0, right, is available in this R2. But as it matches with this prefix list, right? But 10.1.3.0, while it does not match with this prefix, right, it is rejected. So we have to just fix this prefix list, right? And ideally, the other route should also be accepted. Okay. So um, how we can do that? Correct. Let's try to configure conf. Right. I will copy paste this prefix list, right? And right, I want the third octet to be matched as well, right? So 10.1.3.0, right? This will match 10.1.3.0 as well, right? Because now earlier it was more specific, right? /24. Therefore, it was not matching 3.0, but now it should match. Okay. But when we if we just use this command, right, configuration, then it will match this exact prefix, right? 10.1.0.0/16, right? We want to match, right, anything which is starting from here and ending till /32, right? Because we have to match 10.1.1.0 also and 10.1.3.0 also. Both are in /24 range, right? So we will use less than equal to 32. If we'll just use 10.1.0.0/16, it will not work. Okay, because of this specific match /16, it won't work, and our prefixes which are coming from the R1 side are /24, right? So therefore we use this less than equal to LE is less than equal to 32, right? And uh, now let's see the configuration, right? Now we are seeing that the earlier prefix list we have changed, and now this is the prefix list, right? Let's see what happens now. Yes. And after we change this uh, prefix list, right, we are seeing that we are receiving two routes now, right? Same can be verified using the command which we used earlier, right? Yeah, now we can see that both of the routes are injected, right? And both are coming from 65001, right? Which is our AS from R1, right? Now from here, we are advertising to our neighbor also two routes, right? So this looks fine, right? From R2's perspective, this looks fine, right? We will go and check on R3 now, just mapping the path, right? So from R1 to R2, we have the routes now. Now let's see on R3 if we are receiving both the routes or not, right? BGP summary, right? I'm getting two routes from 23.0.1, which is from my neighbor R2, right? But I am not sending any of them, right? Now, why I'm not sending the routes which is received from R2, right? Let's see the configuration. Now, here in this configuration, I am not seeing anything different, right? Here there is no prefix list, right? Or no route map or nothing, no filtering basically, right? Which is preventing my routes from coming from R2 to R3, right? Or from not allowing the routes to go from advertised from R3 to R4, right? Even then, R3 is not advertising the routes uh, to my neighbor, right? So and the vice versa also, right? If you see, we are receiving one route from our neighbor, right? But we are not sending that back to 23.0.1, right? So there seems some internal mechanism which is preventing it from, being the routes being propagated from here, right? So let's look at, let me bring PPT up, right? And let's look at some of the a brief overview, right? What is BGP and few of the things related to BGP, right? We know that BGP can have two types of connection, right? An eBGP and an iBGP, right? eBGP is basically between different ASs, right? Where we have between R1 and R2 and between R4 and R5, we have different AS, therefore a different, therefore there we have an eBGP link, right? Connection, and otherwise, if it is in the same AS, we'll be using iBGP, right? Now, between eBGP and iBGP, there is a difference in route sharing, right? So routes which are learned from eBGP, right, are advertised to iBGP, right? Routes which are learned from iBGP are advertised to eBGP, but routes which are learned from IGP, iBGP are not advertised further to any other iBGP peer, right? And this is known because this prevent loops basically, right? And but it has some impact on network design, right? Because in our case also, R3 is receiving route from R2, right, which is an IBGP member, IBGP peer, right? And it is not forwarding the route to R4, which is another IBGP, right? So we are seeing this kind of thing happening in our lab also, right? Where the route which are learned from one IBGP neighbor R2 is not being shared with another IBGP peer R4, right? Uh, Here is our basic BGP path selection mechanism, right? First weight is preferred, right? Then highest local preference, local origin, shortest S path, lowest origin, then lowest med. eBGP is preferred over iBGP, right? Lowest IGP metric is preferred, then oldest path is preferred, then lowest router ID is preferred, right? This is not anything applicable to our lab as of now, right? But just discussing in because this is one of the core concepts from BGP, right? Um, we discussed prefix lists just now, right? Just giving a brief glance that we use prefix list to match a series of IP prefixes, okay? And we can permit or deny those prefixes, right? Those prefix can be very specific, right? Like 10.10.0.0, right? Or it can be less than equal to, greater than equal to, right? There are multiple variations of that. Okay. Similarly, we have another concept of route policies, route maps. Okay. And these route maps are like if-else conditions. Okay. If you're taking from the programming world, right? Then if it is like if and then statements, right? It is a more powerful mechanism than prefix list, right? Here we can, change a lot of the BGP, which we were path selection, we were saying, right? We can manipulate the lot of those things, BGP path selection through this route map and route filtering. Okay, not going in very detail, right? Now, the problem which we were discussing earlier is called as IBGP split horizon, right? So an IBGP router does not advertise its routes learned from one IBGP peer to another BGP peer, right? Um, this is because IBGP has a full mesh requirement, right? That every IBGP router must pair with every other router, right? And this will create this creates a lot many sessions, right? And to prevent that loop, right? We will use IBGP split horizon, right? Now, but there is a problem here that if we have the full mesh requirement, right, as the network will grow, right, since the number of sessions we are saying n into n minus 1 by 2, right? If you're adding a new router, right, this session will increase dramatically, right? But we have a solution for it, okay? That is called as route reflector, okay? So route reflector is just to prevent this IBGP split horizon, right? And it will remove the requirement for full mesh as well. Okay. Just for this example, right? In our case, correct, we will have a route reflector, right? All these other routers, right? For example, C1, C2, C3 will act as a client to this router reflector, right? And they will advertise the routes to our router reflector, right? Between C1 and C2, they won't advertise the routes. Okay, all of them will advertise it to router reflector, right? Route reflector will then advertise it back to other routers, right? Other client routers, right? So what will happen is, since C1 and C2 are not communicating directly with each other, right? There is no loop which is happening here, right? So all of RR will act as a central place to basically collect all the routes, right? And then send it back to all the clients, right? All the other routers which are connecting to the route reflector, right? Here we have only one route reflector, but we can have primary backup route reflector, right? Based on our configuration, right? We can have multiple route reflectors also, correct? Based on configuration, we can have policies where we can only allow specific routes to our specific group of clients, right? For example, C1, I want to send only specific routes. All that can be achieved through various means, right? So is a BGP router that reflects IBGP routes, right? It removes the requirement for full mesh, and RR bypasses the split horizon rule, right? RR routers connected to the RR are called as RR clients, right? So we have the problem and we have the solution as well, right? So the problem is that um, if you talk about the problem, right, R3 is connected to R2 and R4, right? Whatever routes we are getting from R2 are not being passed on to R4. Whatever routes we are getting from the other side, R4, are also not being passed on to R2, right? So that's the problem, because these routes are being received from IBGP peers, right? So they are not being forwarded to other IBGP peers, right? But we can solve that problem, right, if we convert R3 into a route reflector, right? So if we convert R3 into a route reflector, the split horizon which is happening, right, which routes are not being shared from one IBGP peer to another IBGP peer, that will be solved. Okay. So let's go ahead and configure our R3 as a route reflector, right? So we are in uh, this. It is configured under address family. The configuration is pretty simple, right? There is no configuration as such from the client side, right? So we have two neighbors, right? 10.23.0.1, right? We will configure both of them to be our client. Okay. Basically, both of them will act as a client. Okay. Now let's see the. Let me go back. Like, now we are seeing it, right? That we are having uh, routes which is being received from 2 3, right, and being sent further, right? We are seeing this 3 and 3, right, because of how the operating system of FRR works, right? So for FRR, even before sending the routes to particular um, neighbor, right? These numbers are a little mismatch, right? This number shows even before they are sent to the neighbor. Okay, so after sending the neighbor, what is the actual what is being received on the neighbor, right? We can check on the R4, right? So let's check on R4. Let's connect to R4. So IP BGP summary, right? Yes, so we are receiving two routes from 3 4, right? And which is expected, right? We should receive two routes. Okay, but we are seeing that the routes are not being sent further properly to R5, right? We are seeing only one route being sent, correct? And why is it happening, right? If you try ping also, right, um, it will fail, correct? Because the routes are not being sent properly from R4 to R5, right? So we can check this specific route, right? 10.1.1.0/24 was our route, right? Uh, uh, it says not advertised to any peer, right? It says 10.23.1.0.1 is inaccessible, correct? So what 10 our next hop should be the route reflector, right? But this next hop route looks like on R2, correct? So since R4 and R2 does not have any direct connection, right? So therefore, this route is not being sent further, right? This route is actually not a valid route. Okay. So therefore, it is not being sent further to R5, right? And after actually on R3, correct? I have this configured that uh, the routes should be sent with next hop self, right? Next hop self means before sending it back to the other peers, I should um, the next hop should be set to myself, right? Set to R3, correct? That is what I have configured, right? But when I checked further on FRR, right? So FRR has a little bit different um, mechanism, right? And FRR will uh, not set next hop self, right? If it is getting the routes from one IBGP and sharing it back to another IBGP. Okay. So to do it, right, we have to force it. Okay. So there is a command called as force. Okay, which I got to understand from by reading its documentation. Okay. So that can try if it will solve our problem. I will go in address family unicast neighbor. I will force it, right? And I want it on the on both the ends, right? Otherwise, the same issue will happen on R2 side, right? Where the next hop will be R4, but actually the next hop should be R3, right? Now let me exit and check on R4. Now what is the correct next hop, right? Show BGP IPv4 unicast, right? The route was 10.1.1.0/24, right? And I am seeing it is being advertised to non-peer groups right now, and the next hop is on R3 right now. Okay, so there is a rule in BGP that if the next hop is not reachable, right, that route is not valid and it won't be sent and advertised to the peers. Okay, so it's very important from BGP's perspective that there should be the reachability. Okay, either the reachability normally we can have reachability through some IGP also. Okay, but here we don't have any underlying IGP, right? So that reachability is not there from R4 to R2, right? But since we were using route reflector, right, the next hop from R4's perspective should be R3, right? And from R2's perspective, it should be also R3, but that was not happening earlier, right? So this is something which is specific to FRR, right? FRR operating system on this router, right? But yeah, after we do it, right, we can see that all the all the routes are now being sent, right? Are being sent to uh, our neighbor router, right? Now let's log in into the bash of R1, right? And let's try pinging our files, right? So from here we can see that we can ping the router of the routes for R5, right? So this is how we solved. We had two issues, right, on our lab. Okay, one was for prefix list, right, and one was for split horizon, where we got to learn about route reflectors, right? And while doing all this, we also understand about one another small issue which is specific to FRR, right? But it is one of the constraints in BGP that if the routes are being it's not valid route, right? If it is it does not have a next hop reachability from our router's perspective, right? So we got to understand that as well. Yeah, thank you for watching the video.